All right. So rotations. So because of quadrants, quadrants are numbered 1, 2, 3, and 4. So when we rotate this way around the quadrants, it's a positive because you're going in order of 1, 2, 3, 4. When we rotate this way around, it's negative because that's opposite. Okay? So if we go and we're going to rotate this little triangle here 75 degrees, we around P, we draw a line to P and we rotate 75 degrees, and we'd use a protractor for that, but we're not going to use a protractor in here for this. So Z, we draw a line to P, and then we're going to rotate 75 degrees. And then Y, we'd rotate 75 degrees. So it'd be somewhere around here. So then this triangle's rotated this way. Now, it's not going to be that complicated when you guys do it. But let's get the rotation vocabulary word written down first, and then we'll get into how we're going to do most of ours. Austin, are you writing the vocab word down? Or you don't have your stuff with you? Okay, okay. So a rotation rotates every point in the pre-image around a point P called the center of rotation. The center of rotation is the P. And the angle it rotates around is called the angle of rotation. How far it rotates is the angle of rotation. Okay, so this one was rotated this way. Okay, it's just a simple rotation. Now, for most of ours today, we're going to rotate around the origin, and we're going to rotate a very nice number of degrees. We'll either rotate 90, 180, or 270. So this chart, I want you to write down in your notebook or somewhere because that is helpful. That's a very helpful chart. So if you rotate 90 degrees around the origin, you just flip-flop the ordered pair and make what was y the opposite sign. If you rotate 180 degrees around the origin, you keep the x and y in the same order, you just make them both the opposite sign as what they were before. And if you rotate 270 degrees around the origin, then you flip-flop the x and the y, and then you make the x the opposite sign of what it was originally. Okay? So if you know those numbers, that'll help you out. All right, so let's do a 90-degree rotation of the point 1, 2. So then it'd be the point 2, 1, and what was the y becomes negative. So it'd be negative 2, 1. Negative 2, 1. It'd be right there. Now, does that look like a 90-degree angle? Sure does to me. So then 180 would be the point 1, 2, and both of them would have opposite signs, so it'd be a negative 1, negative 2, negative 1, negative 2, right there, which then makes a 180-degree angle is a straight line. That looks like a straight line. 270 degrees, you switch the x and the y, and you make the opposite sign out of what originally was the x. So it's 2, negative 1. Okay? And this is 270 degrees because it's 90 degrees plus 90 degrees plus 90 degrees. 270 degrees. Okay? There you go. So how would we rotate this 90 degrees around the origin? Well, if we know the ordered pairs, A was at 3, 5. So A, since it was at 3, 5, A prime will be at 5, 3 with the y being opposite. So negative 5, 3. That's A prime. B was at 1, 7. So B prime will be at negative 7, 1. C was at negative 2, 4. So it'll be at negative 4, negative 2. And D was at 2, negative 1. So it'll be at 2, 1. And then, no, it'll be at 1, 2. And since the y was negative, it becomes positive. So positive 1 up 2. So that's a 90-degree rotation because this rotated this way 90 degrees. This rotated this way 90 degrees. So a 90-degree rotation, they should wind up in one quadrant to the counterclockwise from where it's at. Okay? What's 180 degrees across from A? What would be the ordered pair? Well, right now, A is at negative 2, 4. What would A prime be? 2, negative 4. Right down there, because that's 180 degrees away across the origin. Okay? You leave the numbers in the same order, you just use the opposite signs of both. Okay, marching band. Okay? At the start, they're lined up A through B this way. Okay? And then this whole line goes 180 degrees around A. So A doesn't move, so A prime is still A. And B moves all the way around here. It rotated 180 degrees. Then that's 180 degrees counterclockwise. Then they're going to rotate around B 135 degrees this way. So the composition of rotations, the first rotation, which we use a small r, we rotated around point A, and it was 180 degrees. The second rotation, and we have to work right to left when we do composition and transformations, we rotated around point B here, and it was 135 degrees, but it was 135 degrees clockwise, so it's a negative 135 degrees. Okay? So that's how you write a composition of transformations. So for this one, how do we write it? Well, first, we ran around E this far, okay? Clockwise around E. So we rotated around E negative 60 degrees. And the second one that we did, we rotated around C 60 degrees back. Okay, so that's the composition of rotations. Now, when you have a double rotation, or a double reflection, if you reflect across the line and then reflect across the line again, remember how if there were two parallel lines, you went 2 times the distance between the two parallel lines? Well, what happens here is you're going to go 2 times the angle between these two, is how far you rotate, how many degrees you rotate. So if the angle of these two lines is like 45 degrees, then it would be like a 90-degree rotation. Okay? All right. So I'm not so concerned about this rotating. You just have to know it's twice as much as what the initial angle was. But knowing how to rotate is a big thing. And knowing your chart from here will help in most of your problems today. Okay? So you have to finish up the reflections assignment and then do the rotations assignment. So there's 2 assignments to do. So there you go. You have plenty of work. We'll have a couple quizzes next time. And then only 1 section next time instead of 2.